Welcome
to the joy of coding.
Hello! Hello, and welcome to episode 153 of The Joy of Coding. My name is Mike Conley. Hopefully you can see and hear me. I had some minor networking issues. That's why I'm starting just a little bit late, but I think I'm up and running now. I apologize for the lateness. Let's get into it. What am I doing? Right, so first of all, let me share my screen. Show you where I'm at. Things are a little scattered. That's okay. Here's my screen. I'm on the right screen. Good. Okay. And today is October 17th, 2018, episode 153. A reminder, as per usual, no plan survives breakfast. Things might go horribly wrong, just like my networking during the start of the stream. I might even misspeak. That's okay. None of this is planned. None of this is pre-scripted. I'm rolling completely off the cuff here, trying to capture software development in the raw. So if things go wrong, that's okay. It's all part of the plan where there is no plan, really. I have a sense of what I want to do. That's why there is this agenda. But who knows how it'll go. It might go horribly wrong. We'll see. That's part of the fun. Whoops. Am I back? No plan survives breakfast and glitches. That was a bit of a glitch. Sorry about that. Let me reset my camera now. There we go. Sorry about that. There is a a power button connect. So all of my USB stuff, my monitor acts not only as like a monitor but also a USB hub. So the camera, the microphone, my headset, everything goes through the monitor, and I accidentally bumped the power button. So there's a single point of failure. Sorry about that. Where was I? Oh yeah, the agenda. So this agenda is something you have access to. If you're watching this on YouTube, go down to the video description for a link to the agenda. If you're watching this on the new Air Mozilla, it's right over here in the handout section. And if you're watching this on Twitch, then I'm going to drop a link into the Twitch chat right now. Hold on, Twitch chat folk. There you go. So there is a link to the agenda, and you can follow along. There's an episode guide, I want you to know. An episode guide here that is completely viewer-driven. If you need to know about the contents of a certain episode or something, these episode guides are pretty handy. They'll let you know what I covered. They'll have links to the agenda as well as the bugs I worked on, some of my notes maybe. Handy stuff, and it's completely viewer driven. Big shout out to Smurf D, who I think is like the primary contributor to this repository. So if that is a thing you feel like contributing to, because maybe you have your own notes, or maybe you want to correct some notes, or who knows what you might want to do, supply some useful information to other viewers, send me a pull request to the repository. And if you're not sure what I mean by that, here's a contributing guide in the agenda, as well as links to information about what a pull request is, what a repository is, and a guide for creating a pull request. Okay, so let's get into it. First of all, a quick self-check. Am I recording? Yes. Can you hear me? Yes. Can you hear the sounds? Oh, hopefully you heard that. I didn't hear it, but that's probably because... There we go. Yeah, because of the power switch thing. So we're all good. Let's keep going. What are we doing today? Well, first of all, I want to review some patches. I got some patches in my queue yesterday, and I want to look at them today. So let's start our day by looking at some patches. So let's pull these up. So first of all, we got some performance telemetry. Well, let's take a look at the bugs too. Before I look at patches, I like to look at the associated bugs just so I know what's being addressed here. What's all this about? So let's go to the first one, and we'll look at the Bugzilla bug. And this one's a different bug, and this one is another different bug. So we have 3 individual bugs, and let's see what the order is in actually. here's what I'm going to do. I'm going to look at the stack. Where's the stack? Here. There are a number of patches here. 1, 2, 3, 4, 5, 6, 7, 8. And there are a number of different bugs being covered, mostly 1446161. And there's 2 for 1487287. So there's 1, 2, 3, 4, 5 bugs being covered here. And it seems like this is the root bug. 1488993 is the first bug. And then 1487287 is the sort of the leaf of that stack. So I guess this is what this is all about. I seem to recall what this patch set is all about. To summarize, when we create a content process, or any process really, the parent process blocks until that process has started and has started responding, which is a great way of making sure that that process is, running, and we have a process ID for it synchronously. But sometimes things get in the way. I actually was talking with someone, I think over Twitter, or maybe it was a Reddit commenter or something, where they showed me a profile where the parent process was hanging for a couple of seconds, I think, because some of their antivirus software, I believe, some security software, was running a scan on the content process, or the new executable that was running whenever the parent started to launch this process. And the parent's blocked. The parent just hangs while the scan is underway. And that's terrible for performance. It's terrible. So I believe this patch set is about making process launching asynchronous, which is what you want. So let's take a look at the patch set. Now, I'm not the reviewer for all of them. I'm just a reviewer for, I think, 3 of them. But I like to understand exactly what's going on before I review. So let's start with the first patch. Fix preallocated process manager blocker management. This is the first patch in the series. I am one of the reviewers for this. And let's take a look at its bugs. So Jed, who's the assignee, the person who wrote the patch, Jed is saying here that he found some issues with preallocated process blockers while working on this other bug. Preallocated processes themselves don't need to be blockers. Preallocated process manager currently supports at most one process, and if we support multiple concurrent launches in the future, it's not something we do accidentally. Remove blockers and called in some error cases if the process fails to launch or is destroyed for reaching receive first idle. In that case, a blocker would be leaked and we'd never pre-allocate afterwards. Right, and I believe I reviewed this not that long ago, but it bounced. We do clean up blockers and active destroy indirectly via the IPC content shutdown observable. Previously, the preallocate process will remain a blocker until it had created its first tab child and then reached an idle state. With this patch, the next preallocation is allowed as soon as the process is taken. However, there's at least a 1-second delay before it will actually try. Parent main thread idle followed by a 1-second timer. So that may not matter in practice. I was going to back... Oh, that's good. Main thread idle. That's good. I was going to back the patch out while I reconsider, but there are info problems. Profile in Linux from the first pre-browser constructor, the following main idle. Sure it is. This might not make a difference in practice, this sort of idling. So, and then 27 days ago, Jed writes, I tried another approach to this, leaving as much of the existing behavior intact as I could without breaking the future async launch change by moving the add blocker calls to immediately after launching for normal launch or after pre-allocated process manager take for pre-allocated. We don't need to have a blocker while launching because this is all in the main thread. That almost works, and it almost means that the assertion and remove blocker could stay, but it failed intermittently on try. The failures are because the preallocated process was already registered as a blocker when it was taken. The only thing I can think of that would cause that would be if a newly launched process is recycled and then retaken all before receive first idle, which is certainly possible. If it's possible for a process to be launched and then recycled without ever having a p-browser created, that makes this more plausible because in that case the first idle run won't have been scheduled yet. So I'm leaning back towards just not making preallocated process blockers at any time. This fixes and /adjusts 2 things about how content process preallocation is blocked. Processes aren't registered as blockers until after they launch successfully. The main goal is to not leak a blocker if launch fails, but we don't need to block while launching synchronously because this all happens on the main thread. Pre-allocated processes themselves aren't blockers. The main goal here is that async pre-allocation doesn't need extra complexity to avoid being blocked by itself when launch completes. This mostly doesn't affect actual behavior because we currently support at most one pre-allocated process. The difference is the window from when the process is sent its first p-browser constructor until when it's next idle, where there is now no longer a blocker. Difference is the window from when the process is sent its first constructor until when it's next idle, where there is no longer a blocker. But this seems to be relatively short, about 100 milliseconds. And we don't even try to launch a new process until at least 1 second and an idle runnable. This patch does not explicitly remove blocker in Act Destroy like the first attempt did because it's unnecessary. It's handled in the IPC content shutdown observer. Right, which I had missed in my first review. So let's take a look at the patch. So we stop, like he's saying, we don't block anymore until after the process is launched. Right here. Because we don't need to. Or, where are we here? Get new or used process. This one blocks, I think. This one doesn't. We don't block. And just to refresh my memory, I'm going to make sure I understand what a pre-allocate process manager blocker is. Before first paint, we don't want to allocate any processes in the background. To avoid that, the pre-allocated process manager won't start up any processes while there's a blocker active. So it's a thing that you can create that will prevent pre-allocated processes from attempting to from trying again. And Jed is saying that there's no need to block here because we're in the process of pre-allocating, and because it's all happening on the main thread, there's really no, and this is, I believe, still synchronous, there's no chance of attempting to pre-allocate. Right. Async pre-allocation doesn't need extra complexity to avoid being blocked by itself. This mostly doesn't affect actual behavior because we currently support at most one pre-allocate process. Right. So now there is no blocker in that window, but that window of time, process sends first browse constructor until when it's next idle. So there's, this used to assert that the blocker existed, but pre-allocated processes aren't blockers anymore because it's not useful. It interferes with async launch. And it's simpler if content processes don't need to remember whether they were pre-allocated. And pre-allocated processes can't add blocker when taken because it's possible for a short-lived process to be recycled. I can't add a blocker when taken because it's possible for a short-lived process to be recycled through provide and take before reaching receive first idle. I think this makes sense. The window from when the process is sent its first p-browser constructor until when it's next idle. Now there's no blocker. Let's see where else we add blockers. Oh, there's only one place. Here. So what's he saying? This part most one. let's take a look at the pre-allocated process manager again. Let's actually look at the code itself and not the enabled and pre-allocated process. When does that, when we do allocate now, it's in content pre-allocate process. And that's when we were adding a blocker. Async pre-allocation doesn't need extra complexity. I know I'm rereading this stuff back and forth a bunch. I really just want to understand it. Once I understand it, hopefully I'll explain it. Processes aren't registered as blockers until after they launch. Okay. Don't leak a blocker if launch fails. And we don't need to block while launching synchronously, because it all happens on the main thread. The main goal here is to avoid async, so that async pre-allocation doesn't need extra complexity. Because we currently support most one pre-allocate process. The difference is between when we first send the p browser constructor until next idle. So yeah, idle. Allocate on idle. That's when we allocate now, is after the idle. Delay dispatch to current thread, allocate after delay, allocate on idle. Idle dispatch. We use idle dispatch to wait, so we use the low priority queue. So we send the first p browser constructor. When would we do that? We send the first tab. I think there's like, he's talking about the recycling. Remove block, can allocate after delay, provide, and then take. Provide, try to recycle here. When would we try to recycle? Right, so he's talking about the recycling. So when a tab has been destroyed, let's say we have the pre-allocated process, it's created. Then let's suppose we take it and then create a tab in it, but then destroy that tab really quickly. Then in the notification of the tab being destroyed, we will attempt to recycle the content process if the lifespan is less than 5 seconds. And we'll put it back. And so what Jed is saying is now there's a window of time where we are not blocked from creating a new pre-allocated process during that window where we might recycle. But that's okay, because the next attempt to pre-allocate will occur after 1 second and an idle runnable. And even then, if we'll attempt to recycle, where is it? We'll attempt to recycle, and if we don't We might get a call from both. Right, because we can only ever have just one. So even if we try to recycle, we might fail to recycle. That's okay. And that's a small window of time. Difference is the window from the process sends first constructor until when it's next idle, where there is now no longer a blocker. There's a short period of time. We don't even try to launch a new process. Right. Okay. So I'm gonna, I like this. I think this works. I'm gonna quote this. How best to quote? Like that. Right. I'd forgotten it did that there. So it sounds like even in that 100-ish, or even in that window where there is no blocker, because there can only ever be one content process, there is no, even if we managed to recycle that content process, the old content process, recycle a previously if we manage to recycle a content process and then attempt to pre-allocate a new one, this would just bail out because of the pre-existing recycled process. And if we did happen, and similarly, if we did happen to pre-allocate a process just before the recycling occurred, then we'd just end up killing that old process instead of attempting to recycle it. Both sound fine to me. Thanks. So that makes sense. It's not useful interferes with async launch. Simply if content processes don't need to remember whether they were pre-allocated. Okay, I like it. So I'm going to accept the revision. Great. So that's one. Right. And what's the next one? This is updating some telemetry. The content process launch time millisecond histogram is currently gathering times from two different spans of the launch process and mixing them together. It's at best a rough approximation of launch time. In addition, with async launch, we want to gather different metrics than for sync launch. Therefore, I've taken the opportunity to create a new histogram for sync launch time. Time elapsed during synchronous content process launch until the process is usable for loading content. Two different spans of the launch process and mixing them together. What are the two spans? Let's take a look and see how it currently works. Okay. We accumulate here whenever we call launch subprocess will launch timestamp. When is mlaunch timestamp? Oh, that's when the content parent is created. Oh yeah, that's a mess. That's a mess. Yeah, that's no good. So we have two different ways that we're two different places where we're measuring content process launch time. Here's the other one. Init internal. And init internal is called when content parent init internal. So here and then here. So what? Yeah, we have these two places. So he's getting rid of one of them. And then here we're saying, yeah, he gets rid of this one and this one. Instead we go here. Time lapse during synchronous content process launch till the process is usable for loading content. Oh yeah, that's way better. Oh man. I seem to recall this being a thing at some point. Just quickly check. I thought it's not useful anymore. This histogram used to measure the time between starting to launch content process and when we receive the first message from it. Now it measures launch time, which is a lot less useful. It would be easy to make an async message file. Also, point that probes accumulate twice. I'm sure just adds a little bit of noise. So I'll mention that we can probably close this now. Oh yeah, I'd forgotten about this. Thankfully, it means we can close bug such and such after this lands. Thanks. I want to gather different metrics. What metrics will those be? Process telemetry. Content process launch is sync. Launch total. Time lapse from start of async process to the launch promise is resolved and the content parent can be sent IPDL messages. Main thread. Time consumed on the parent process main thread during async content process launch. And then launch for any Gecko child process. The time taking the common process launch code, which is run off of main thread. Async content process launch don't have async in the name because that will eventually become the only kind of content process launch. The probes restricted to async content process launch don't have async in the name. Right, okay, I understand. Good. Good. That makes perfect sense. Thankfully it means we can close that. So I'm gonna accept the revision. That looks good to me. And then what was the last one that I needed to review? This one. Used to calculate async launch main thread time. Okay, so here's where we measure whether or not we are sync or not. So let me take a look at the histogram definitions. Is sync. Kind, it's a Boolean. Whether a common process launch was launched synchronously, unnecessarily delaying UI response. Good, and then we're going to probably whittle this down. And then this one, launch total time elapsed during asynchronous common process launch till the process is usable for loading content. It's opt out. Some bug numbers, JLD. We should have some redundancy here on the opt out. Okay. Are we sure we want this to ever expire? We recently marked tier 1 performance probes as never expiring because we feel there'll always be something we want to track to ensure product health performance in the wild. Tier 1. This was the bug for that. As async process launch is likely something we'll want to track indefinitely. I suspect async process launch is something we'll launch health performance is something we'll always care about. So perhaps this should be never expired. Main thread time spent during ACE. See below. Same reasoning. Also, redundancy here. Shows here on. We should probably also notes here on the opt out. Alert emails wise. Who is Jed's manager? I'm guessing we'll probably want to put Jim Matthews on this. Let me just check and see who Jed's manager is. Perhaps we could put Jim as a fallback here. I also volunteer as a third here on these. Okay. Same. See below, same reasoning. Okay. So we have four new probes. This one measures whether or not launch is sync or not. This one measures the amount of time total for async process launch. This one is how much work is being done on the main thread for async process launch. And then this one is time spent off the main thread. Wait, time spent in the generic child process launching code, not including content process specific work. I think that one I want to understand more. Child process launch MS. That's this one in the what process is this? I suspect this is the parent process. This is all in the sandboxing code. What function is this? It's in a function called oh man. Let's find out. Let us oops. Function all very OS specific. Perform async launch. This is done on the main thread. Start TS. Start TS. Where's that come from? Start TS. It must have been added earlier. Right here. Form async launch. So it's from the start of async launch to here. And I think that occurs off of the main thread. Perform async launch. I suspect that that's what that means. So let's find out. Perform async launch. Run perform async launch. Yeah, right here. So it happens off of the main thread. Okay, so that's what it's doing. It's measuring how long it's taking for us to actually launch the process off of the main thread. Not including content process. Time spent in the generic child process launching code. Should we mention that this is occurring off of the main thread? Okay, so I think that makes sense. Okay. Launch. Then here, launch yield TS is time spent stamp now. What's going on here? This is we're looking in the content parent used to calculate async launch main thread time. So here's where we say whether or not we're sync or not, whether we're sync or not. Implicit conversion from a bool to uint32t. Okay. And then over here, where are we? Some kind of resolving code, some kind of lambda. What function is this? In the content parent in launch subprocess internal. Launch sub, so we're in the process launching code. And launch resume time is from here. And init done time is here. Total time synchronously. Gotcha. So if we're doing it sync, then we do it here. Otherwise, we get the launch yield time minus the initial launch TS plus the init done timestamp, which is now minus how long it took us to resume. Resume timestamp, which was here. Here minus here. So that's all of the time on the main thread. Okay, I get it. All of the time on the main thread. Launch total is total time. And then that's just the main thread time. That makes perfect sense. Okay. And then here is launch yield time. Launch yield time. Is whenever I think we hand off to the other thread. We're just waiting for the other thread to finish launching the process. Okay, that makes a lot of sense to me. This looks good. Yield. Okay, I think that does it for me. Yeah. Looks great. Just a few notes. See below might not be the right term because hang on. Instead of that, I should go here. See my comments on that. Yeah. See my comments on same reasoning. Otherwise this looks great. Just a few minor comments about the new probes. Code makes sense to me though. The code gathering the times makes sense to me though, insofar that I understand how the async launching is working. Okay. And I think that takes care of my reviews. Hooray! We can play a sound to celebrate. I like doing the air horn. That's great. For the folks who work on Mozilla code, maybe and sometimes get like review requests, you'll notice I have this add-on here in my browser. It's probably difficult to see what's going on here, but that's a little counter. And if you rewind the stream after it's done, and you go back to the beginning, that used to say 3, now it says 1. What it's doing is it's counting how many reviews are in my queue. And I actually now have 0 reviews in my queue, but it's only going to update after every couple of minutes. And this works for both Fabricator and Bugzilla. It's a little add-on I wrote called My Queue Only. And if you want a copy, you can get one. And that's what it looks like zoomed in. And I'm going to put a link to that in the agenda. And if you're curious about how it works, the source code is, for some reason my browser icon's all messed up today. Today's nightly. Here's the source. All right. What are we doing now? It's just before 2 o'clock. I want to quickly see whether or not I got some reviews in for a different bug. I'm just going to quickly check my email on my phone because I don't want to do it in front of you here. What are we doing? What are we doing? I just want to see whether or not there's some stuff we can land. Doesn't look like it. Okay. Let's see. There's other things that we might be able to land depending on how they're doing on try. This here is a stack of patches that should make it easier for us to launch. Oh man, are these as broken as I think they are? Oh, maybe that's just an intermittent. Some of these look like intermittents, so that's probably okay. Actually, I was hoping we could look at that next. I think I want to land these. But maybe not today. Maybe just after soft freeze ends, I want to land them and then figure out what's going on. Because so these patches for I don't know if we worked on this last week, did we? I think we did. So that's making activity stream run in its own content process. Whenever I turn on the separate content process, I get these wacky test failures in some of our web platform tests for reasons that are completely beyond me. So I was thinking I might land the other patches that do not land the other patches that, except for the part that where I turn it on by default, but we're so close. We're in soft freeze right now. That should ease up after Monday, so I'll probably land them after Monday if I haven't figured out what's causing them to fail. Even though I do figure out what's causing them to fail, I'll wait until after Monday to land anything. Because I was thinking, maybe I can just land the bulk of it except for the part that turns it on, and that way I'm not going to need to continually rebase these things as the tree evolves. So I've got, let's see here, where is this terminal? We zoom in, and then do that. I've got the patches applied to my Linux VM beast mode. Let me sign in. And yes, I can definitely reproduce the issue. If I run the test here, I'm using a debug build. So this might take a couple seconds, but we should see some test failures. And I'm completely at a loss to explain it, and so maybe we can figure it out together. So what exactly am I testing? Let's start by looking at the test itself first. So while that's running, let's open up the test. Fetch destination. So this is the fetch API, which, makes it easier for you to make requests to other places on the web without having to do the old school hand roll XML HTTP request stuff. It's like it's a much simpler way of doing requests without needing to set too many callbacks. You use like promises. It's very promisey, which is nice, and it lets you do like off main thread decoding of responses. It's very good. So how does this test work? I don't know. Let's find out. This is a test suite that I'm not super familiar with, but what's nice is that the web platform tests are shared between browser vendors. So this test is, I believe, run by Microsoft, by Google, by Apple, by any serious web browser engine should be running these tests to ensure that they're web platform compliant, that they're properly satisfying the needs of the web. So that's kind of neat, the fact that it's so generic that it can be run on different engines. But that also means that I can't just start updating this test willy-nilly. Almost certainly this test is not what needs to be fixed. Something in our code needs to be fixed, because these tests are written by like spec professionals who know how the spec's supposed to work. So it's not like the spec's busted, or at least that's very unlikely. So what is the failure? What was the failure I was dealing with? Great question. Are we there yet? Do we have it? I think we do. If I scroll up, how do I scroll up? Here. Timed out waiting for the browser to start. Huh. I think I don't think this is working correctly. Maybe because I've got maybe the screensaver, maybe my lock is on, the lock screen is on. So let's start up a display server and then run it on display 1 instead of display 0. Let's get VNC opened. VNC, where's VNC? Oh, remote desktop viewer. That's what I've been using lately. Q, R, P, Q, R. Oh man, come on. I used to know how to do this. Remote desktop viewer. Don't I have you somewhere? Did it get removed? Yeah, it's gone. What? Why is it gone? Where did it go? Shoot. Well, all right. Well, maybe we don't need to see it while it's happening anyways. Where did it go? Do I have to do something inside the App Store? Remote desktop. Oh, it's here. This client will soon be deprecated. Great. Oh, man. Was redesigned since last time. The feedback has been incredible. Version 8, and only version 10 will be available. Oh, that's fine. I'll take the newer version. I have the older version. Okay, so let's get the newer version. Let me just quickly install it. I don't think this costs anything, because yep. Okay, installing. So I'm installing the new one. Meanwhile, I can open up the old one. What? Or is there a different tool I was using? Man, oh, I was using VNC Viewer. That's what I was using. Not remote desktop. Beast Mode 1. That's what I need. Sorry for the delay. Here we go. What's the story here? Is the test running or not? Timed out waiting for the browser to start. That's no good. What the heck? Let's try that again. It doesn't actually have to be on screen, does it? That'd be crazy. I saw this working before. Running a server. All right, now do it. Do things. What are you waiting for? This is not working. All right, so that's less helpful than I wanted it to be, which is crazy because this was totally working before. What's the problem? Let me go check to see. I'm going to leave the station for just a quick second. I'm going to go see whether or not display 0 is working okay, because this was totally reproducible on display 0 before. And I don't need this anymore. I'm going to quit that. Don't need it. Be right back.
Mamma mia!
Okay, let's try it again on display 0. So I don't need VNC viewer anymore. Starts up a server. Startup observer failed. Failed the subsertion. What's going on here? I didn't screw up my build somehow, did I? Why is this not working all of a sudden? That is the mystery. This is a mystery. Huh. Very interesting. What about if I use the default configuration? Let me just quickly make sure I'm in the right place here. Oh, so I had disabled the separate content process, so that should have passed. And I remember it did pass before. So now I'm going to rebuild, build with debug. So that should be pretty fast. While we're waiting for that to rebuild, let's learn what this test does. So let's read it. Okay, so we say that there is this script, a worker, fetch destination worker, unregister and register. So we're registering a thing and we're running something in a scope. Sets up the service worker in the frame. So there's some very interesting things going on there. And then the first one that runs is we create a promise that resolves after we create an image node in the iframe, and then when that image loads, we resolve, and if it errors out, we reject. Okay, great. And then over here we do something similar, but instead we ask for source set and destination equals image. T equals source set. I don't know what that means. HTML image element with the source set attribute. Oh, we set source set on it as opposed to source. Source set, okay. And here we use source set, and this is the same comment, but we create an image, create a picture, and we create a source. We append the source to the picture, we append the image to the picture, and then when the image loads, we resolve. Okay. SVG image element, we create an SVG. Okay, so it's a lot of the same pattern, creating various images and then waiting for them to load, and then we resolve. Now, that's not what failed. I actually have a record of the failure, even though I can't do it locally. For you, I can pull up the old failure. Actually, it's much more recent than that. It's like right here. Oh, come on. Pull up. Pull up. Give me the info. Here we go. On a link element while prefetching with an empty string request destination. And there is an intermittent here, but that's for reached unreachable code. That's not a timeout. Here's another one where we timeout right here. So this one sounds most relevant, and that might be interesting. This was filed a month ago. This didn't reproduce today's base simulation during the last days of May. Failures have popped up and also on trunk. So the test itself is a little flaky, even without the separate activity stream content process. Why would that be? What does this test do? Which one is it? It's HTML link element, which is down here. HTML link element with rel prefetch fetches with an empty string. Fetches with an empty string request destination. I think it's the last one here. Fetch with an rel prefetch fetches an empty string request destination. Request destination. It's this one. So we create a link. We say rel prefetch. So let's see how that works. MDN link prefetch. What is that? Link prefetching is a browser mechanism which uses browser idle time to download or prefetch documents that the user might visit in the near future. A web page provides a set of prefetching hints to the browser, and after the browser is finished loading the page, it begins silently prefetching specified documents and stores them in its cache. When the user visits one of the prefetched documents, it can be served up quickly out of the browser's cache. Utilizes browser idle time. So is it possible that the browser is never reaching idle time? After the browser is finished loading the page, it begins silently prefetching specified documents, stores them in its cache. Okay. Interesting. Large images. Anchor tags are not prefetched. It is standards compliant. In the current implementation, idle time is determined using progress listener. We attach the listener to the top level web progress object when the document stops loading, and we approximate idle time as the period between the last document stop and the next document start. The last document stop, this occurs kick off prefetch requests after the last unload. All its child frames finish loading. Something's being prefetched. The user clicks on it. Link prefetching will stop, and any prefetch hints will be discarded. If prefetch document is partially downloaded, store in the cache processor, send and accept ranges bytes. Response header. The header is typically generated by web servers when serving up static content. If you're downloading something using link prefetching, will be delayed until any background download is complete. If you load a bookmark group, this is an old feature. This is an old feature. Okay. Interesting. So maybe, I mean, we're never resolving. We're never rejecting. So maybe we're never being scheduled. How long do we wait? Promise test. How long do we wait? Test harness is probably what we want. Resources. Test harness. And what is the test timed out? So where is the that part in web platform tests? Where's the test timeout part? Functional test harness right here. don't get a result before the test times out, that'll be a test timeout. Set timeout. Timeout, set timeout. Timeout length. It's the timeout length. Test environment, test timeout. So I guess oh man. Test timeout can come from a meta tag. In this document, test harness. Is there a harness.html? Test harness.js. Oh, wait, in the test file, might declare one. In the no meta tag. Huh. So that's my theory, is that we're never that we're never idle enough. And why would the content process being in its own, why would the activity stream being in its own content process make that a factor? Okay, I don't know, and I've got to wait for this build to finish in order to find out, I think. Well, let's take a look at the code as it currently exists. Maybe that'll help. And in the future, when this build is done, and hopefully I can reproduce the issue again, we can take a look. We can take a look. Maybe we'll know where we should hook in. Okay, so here's the HTML link element source. I'm going to search for the term preload. When we bind the node to the tree, we'll try DNS prefetch or preconnect or prefetch or preload or pre-render. Oh my goodness. Try DNS prefetch or preconnect or prefetch or preload or pre-render in a link. If it's a preload type, we'll use the prefetch service and we'll preload the URI. Okay. How does that work? Prefetch service. Prefetch service. So thankfully we can log some of this stuff. That's good. This is under what? Neko? URI loader. Okay. So the main interface is probably like to actually init. We'll wait for. We'll observe some stuff. We'll observe some prefs. We'll observe shutting down, and then we'll do. Preload. Takes a URI. Make sure it's valid. Notify load requested. So we message around, say, hey, it was requested. And then we enqueue the node. Enqueued node. So when do we like process the nodes? Observe pref branch. Parallelism pref. Process next prefetch URI. I wonder if that's it. Process next prefetch URI. Start prefetching. Okay, so who calls that? When a web progress has reached state stop. Okay. Add web progress listener. The document loader. Service. So there's just a thing that loads documents, a single thing. Document loader service. Progress list. So we add, there's this like document loader service, and what does it do? Because if it never finishes loading, or if it starts up a load, I can see this failing. Doc loader service. And this has logging too. So if I can get this to fail, this is what I will do. I will start logging both this and load handler. Doc loader is busy. Content process. Why would the separate content process cause it to be busy? Okay, so we have our build done. Maybe we can actually find out. Let's run this test and see if it fails. Come on, do it. I feel comfortable enough that maybe we'd be able to use RR to find things out, but we're also nearly at our end of time, which is too bad because I feel like we're just starting to get into the meat of this one. But I have a meeting I have to run to, so I can't dawdle. Come on, I hope this fails. That would be great. That would be great. right, now it's running the test. Okay, good. So it was just, I had a bad build before. That's weird. I think it's running. How will I know? Well, I could also try running it on my VNC viewer thing. Oh. So, okay, so yeah, it failed. Great, okay. Let's see if we can get some logging now from both the prefetch service and the dock loader. Where was that other code? Yeah. Okay, so I'm going to run that again, but I'm going to set an environment variable. I'm going to say moz log equals ns prefetch 5 and then ns dock loader, or just dock loader 5. And I'm going to set the log file to be debug home, like Conley, yeah, projects Mozilla Central debug.log. All right, run it again, Sam. And maybe we can actually watch the contents of the file whenever it gets created. There. Here we go. Looking good. Running the test now. Stop request. And we fail. What's going on here? Document onload blocker. Is there anything activity stream related in here that might explain it? Can't see what. New tab, .svg. Let's see. What is the file that we attempt to load in this test again? Man, what was the name of that test? Fetch destination. It's called dummy. Dummy. .zool, but that's not it. Dummy.zool. Dummy.zool. Oh, does it? Do I need to? This is all in the parent process. I wonder if I need to be logging in the content process. Yeah, parent. Look at all this. This is all the parent process. I need to be logging in the content processes. How do I do that? Well, I'll find out myself. If you're curious, I'll be taking notes in, let's see, this bug here, or this note here. So I'll put a link to that note inside the agenda. It's actually not this anymore. It's this bug that I'll be working in. And then, oops. And then here, and then here. Boom. Booyah shaka. All right. So I'm going to call it here. Thank you so much for watching episode 153 of The Joy of Coding. I hope that was at least somewhat interesting. Reviewed some stuff, and then I think we have a plausible theory on why that test is failing. I suspect that the content process, for some reason, isn't idle enough, and so the prefetch never occurs. That's what I think's going on. We shall see in the future. Pay attention to the notes, because I will write my findings here in these notes, hopefully. If Evernote loads it. Yeah. Okay. So, yeah. Thanks again for watching episode 153. You didn't see me. I was referring to these notes here. I will see you next week. I will be streaming again, hopefully, and not faking you out and saying I'll miss the episode. So, I will see you next week. Have a great week. Take care. Stalling so I can wake up my laptop or tablet. Take care. Bye-bye.
The joy of coding.
See ya.